Geometric distributions. The geometric distribution is the distribution produced by a random variable x defined to count the number of trials needed to obtain the first success. For example, flipping a coin until you get a head, or rolling a die until you get a 5. A random variable x is geometric if the following conditions are met. Each observation falls into one of two categories, success or failure. The probability of success is the same for each observation. The observations are all independent. The variable of interest is the number of trials required to obtain the first success. Notice that this is different from the binomial distribution in that the number of trials in a geometric distribution is unknown. With geometric distributions, we're trying to determine how many trials are needed in order to obtain a success. The probability that the first success occurs on the nth trial is 1 minus p to the n minus 1 times p. In other words, failure to the n minus 1 power times success probability. The probability that it takes more than n trials to see the first success is 1 minus p to the nth, or our failure probability to the nth degree. The mean or expected number of trials to get a success is found by 1 over the probability of success, and the variance is 1 minus p divided by p squared. The square root of the variance is our standard deviation. The commands for RStudio involve dgeom or pgeom, depending whether we're working with an equality or inequality. We put in k minus 1 or n minus 1 instead of n into this, comma, our probability for success. With the TI-83 or 84 calculator, we have geom PDF for the equals, geom CDF for the inequalities, and this takes the probability first and then where our first success occurs. Let's look at some examples. Example 1. A quarterback completes 44% of his passes. We want to observe this quarterback during one game to see how many pass attempts he makes before completing one pass. So this 44% is his probability of success. Now his probability of failure is 1 minus that, which will be 0.56. What is the probability the quarterback will throw 3 incomplete passes before he has a completion? So in other words, he will have a completion on the 4th attempt. So we're trying to find the probability that x equals 4. Our first success occurs on his 4th pass. According to our formula, that will be 0.56 to the 3rd times 0.44. And that will be 0.0773. If we're using the calculator, we would use geom PDF with the 0.44 and 4. How many passes would he expect to throw? So we want the expected value for our geometric variable here, which is 1 over p. 1 over 0.44 is 2.27. Determine the probability that it takes more than 5 attempts. More than is strictly greater than. And our formula for this was our 1 minus p, or 0.56, to the 5th, to our value right there. This is 0.0551. What is the probability he attempts more than 7 passes? Will be 0.56 to the 7th, which is 0.0173. Another example. Newsweek reported that 60% of young children have blood levels that could impair their neurological development. Assuming a random sample from the population of all school children at risk, find the probability that 5 out of 10 have taken a sample from school and have the blood level that may impair development. The probability you would need to test 10 children before finding a child with a development, and the probability we have to test no more than 10 children. So we have different situations on each of these parts. In the introduction here, our probability of, quote, success is 60% or 0.6. Now in A, we're trying to find out the probability for at least 5 out of 10. So here we have a fixed number of trials. That makes this one a binomial distribution. So at least 5 means 5 or more. That's the same thing as 1 minus the probability of 4 or fewer. Either way, if I use the calculator, I would do 1 minus binom CDF Our number of trials is 10. Our probability is 0.6 and less than or equal to 4. So 1 minus binom CDF of 10.64 would give us our correct answer of 0.8338. Now in part B, we want to know what's the probability that we'd need to test 10 children before finding a child with the blood level that may impair development. So here we don't have a fixed number of trials. We're trying to find our first, quote, success. We want to test 10 before finding a success. So 10 failures, 1 success. In other words, we're going to be looking at geometric, where we want the probability of our first success to be at 11. This would be 1 minus 0.6 to the 10th times 0.6 to the first. And this comes out to be 6.29 times 10 to the negative 5. So almost 0. Now on part C, we want the probability you will need to test no more than 10 before finding a child. So again, we don't know n, so this is geometric. No more than 10 means 10 or fewer. So I want the probability that x is less than or equal to 10. That is the complement of being greater than 10. So this would be equal to 1 minus the probability that x is greater than 10, which will be 1 minus, our formula for the greater than is 1 minus our success to that power. So this comes out to be 0.9999.